Hello and welcome back for example 4. We're going to be discussing some circle applications. So let's go ahead and read this first problem. It says a Ferris wheel has a diameter of 56 feet and makes 15 revolutions per ride. How far would someone travel during a ride? Okay, use 22/7 for pi. 22/7 is kind of the fraction form of pi. No, remember pi is an irrational number that keeps going on and on forever. And I'm just going to go ahead and put 22/7 into my calculator, and then you can see that it is the same thing. So 22, let's see, can you see that? Yeah, divided by 7, and then equals, and there you have it, 3.14, and then it keeps going on and on and on forever. Now, in the calculator, it stops here, and that's because there's only so many numbers that this computer screen, or this calculator screen can fit. So it can't keep putting an unlimited amount of numbers into this screen. So when it comes to the last one, it probably takes the last number and then rounds it. So 22/7 is the same thing as pi. I just wanted you to see that. So it's just in its fractional form. Okay, so back to talking about a Ferris wheel. Okay, we have a Ferris wheel, right? So it's like a circle. And what do we know about a Ferris wheel? It goes around and around and around. So when it says it has a diameter of 56, that means it goes through the middle. That's probably more the middle. Okay, so this whole thing is 56 feet. All right, and it makes 15 revolutions per ride. Okay, so what 15 revolution means, okay, so let's say we start here. Okay, one revolution would be if a person, like a Ferris wheel, right? There's a bunch of people like sitting around here and it just goes around. So one revolution would be going like this, and then that would be 1, and then 2, and 3, and so on, all the way up to 15. So that's how many revolutions per ride. It wants to know how far would someone travel. So the distance here, right, what is this distance for 1 revolution? And then we do it again for 2 revolutions. It's talking about that distance. So as we go, right, this has a particular distance, and then we're going to do it 15 times. What is that total distance traveled for one person in that ride? So when we're talking about this distance around, what are we referring to? If you're saying or thinking circumference, you would be correct. The distance around a circle is the circumference. And remember, there's 2 formulas for that. C equals 2 pi r, and C equals pi d. And do you remember why there's 2? Well, there's 2 because 2 radiuses here is the same thing as 1 diameter. So they're really the same formula, just written 2 different ways, okay? Because 2 radii is the same thing as 1 diameter. So I think I'm going to choose this one because we are given a diameter. So I'm going to find the circumference, okay? So D equals 56. So C equals, and then they say use 22/7 for pi, so I'm going to substitute that in, times 56. And so now I have a multiplication problem with fractions, right? And since 22/7 is a fraction, I'm going to change 56 to 56/1. So remember, whenever we're talking about fractions, we always look to cross cancel and then multiply across, right? So we can't do anything with the 1 and 22, but what about the 7 and the 56? Yes, 7 goes into both. 7 goes into 7 1 time, and 7 goes into 56 8 times, okay? Yeah, so then we just multiply across. 1 times 1 is just 1, so we don't really need a fraction anymore. All we need to do is 22 times 8. So I'm going to do that right here. 22 times 8. 8 times 2 is 16, right? The 6 carry the 1. 8 times 2 is 16, plus 1 is 17. So this means that 1 revolution, the circumference, right, is 176 feet, the distance around this circle. But what do we know? There's 15 revolutions. So that means the distance is going to be the circumference, which is 176, that's a 6, multiplied by 15 for the 15 revolutions, and then that will tell us the total distance. So I'm just going to take that over here and determine what that is. 5 times 6 is 30. Write the 0, carry the 3. 5 times 7 is 35, plus 3 is 38. Write the 8, carry the 3. 5 times 1 is 5, plus 3 is 8. And then 1 times 6 is 6. 1 times 7 is 7. 1 times 1 is 1. 0, 4, 15, 16, 2. Okay, so the total distance equals 2,640 feet. Okay, that is it. All right, now it is your turn, ladies and gentlemen. I want you to go ahead and try this problem here, B. Here's my friend the pause dragon. Remind you to pause your device. Go ahead and work this problem out. When you get done, press play and we'll talk about it together. All right, see you in a bit. Okay, we're back. Let's see how you did. So it says, a bicycle odometer recorded 147 revolutions of a wheel with diameter 4/3 feet. How far did the bicycle travel? Use 22/7 for pi. Okay. Okay, so we have a bicycle with a wheel of, here's the center. Oh man. 4/3 feet. Okay, so that's the diameter. It says a bicycle odometer, so that's just a little device that records the revolutions, so the amount of times the wheel goes around, right? So that's what that's referring to. Recorded 147 revolutions of a wheel with diameter 4/3. How far did the bicycle travel? Okay, so that distance of how far, right, that is referring to the circumference. And so we need to find the circumference, and then once we find that, we just need to multiply it by the number of revolutions, which would be 147. So remember, there's two formulas for circumference, 2 pi r and pi d, right? We're given the diameter, so we're going to use this one. The diameter equals 4/3. We're going to substitute. We're going to use 22/7 for pi, and then multiply 4/3 by that. And it doesn't seem like we're doing a whole lot, are we? Yeah, we looked to cross cancel, but it doesn't look like any of these things cross cancel. And then we're just going to multiply this by, I'm going to multiply it all by 147 and make that 147 over 1. And I want to see if 147 is divisible by 3 or 7, because if it did, it would make our job easier. To see if it's divisible by 3, I would count up the digits. 1 plus 4 plus 7. 1 plus 4 plus 7, what is that? 5, 7, that's 12. And 12 is divisible by 3. That means that 147 is divisible by 3. So I'm going to figure out and determine how many times 3 goes into 147. 3 goes in there 4 times. 4 times 3 is 12. I subtract and bring down the 7. 3 goes into 27 9 times. Ooh, that's super nice. This problem's going to get way easier. Okay, so 3 goes into, and even though there's parentheses here, since they're all multiplied together, it doesn't matter if I multiply these two first or these two first. I really wanted to bring in this 147 because this is circumference, and I know that I'm going to multiply the 147 by the circumference. But if I multiply this before I do this, and then these numbers, right, that's going to be 88, that's going to be 21, then I'm going to multiply it by 147, and I'm going to be dealing with bigger numbers. And so I like to multiply and see if I can cross cancel. And so what's going to happen is instead of dealing with really big numbers, I'm going to cross cancel, and then I'm going to be left with smaller numbers, and I just like working with smaller numbers. So that's kind of my strategy. Since I'm doing multiplication, I can do it to try to cross cancel at the beginning and to make the number smaller. So you'll see. So here we know that 3 goes into 3 one time, and it also goes into 147 49 times. Okay, so now that number's gone. But we can also cross cancel here with the 7 and the 49, because we know that 7 goes into 7, but it also goes into 49. So 7 goes into 7 one time, and 7 goes into 49 7 times. And there we have it. We have 1, 1, 1 on the bottom. So we no longer have a fraction, which is great. And, you know, we can multiply 4 times 22, which is going to be 88. And then we basically just have 88 times 7, which would be 7 times 8 is 56. And write the 5, and 7 times 8 is 56, plus 5 would be 61. So the circumference, no, this isn't the circumference. This is the circumference, but now since I multiplied it by 147, this ends up being the total distance. So this is the total distance. Total distance. And TD for total distance ends up being what, 616 feet. Perfect. So if you got that answer, awesome job. If not, go ahead and fix your work so that your work supports the right answer and you're showing all your work and all the steps. All right, that's it for this example. I'll see you in a little bit for example 5.